All right, we'll get started. It looks like everybody's logged in, so we're ready to go. Just a reminder that we put these recordings on our YouTube channel, so you'll be able to follow up afterwards if you need to review any of it after this class itself. My name is Eric Hayden. I'm a meteorologist with the Weather Service in Morehead City, North Carolina. This is our presentation on severe weather and tornado safety. If you've had some of our other classes, our basic Skywarn, our advanced Skywarn, those were more in depth on how to report information to us. This is a little bit more science oriented, more of a class at the 5th grade level. Anybody is free and open to view this class, but again, it's going to be more science than anything about reporting. If you do want to become a storm spotter with us, we'll refer you to our website after this class itself. We have a lot of online training that you can take. If you've had any classes with us, no matter what class you take, we always start off with who we are, because for some of you, this may be your 5th class with us, and others, this may be your first time. So we like to kind of lay the groundwork for who we are and what we do. Hang tight, we'll get to the main crux of the class here coming up. As far as the Weather Service is concerned, our main mission is the protection of life and property. And we do that through warnings, watches, and also daily forecasts out to 7 days. We've got offices all over the country. So I mentioned that we're located here in Newport or Morehead City, North Carolina. I'm going to get my laser pointer on there. So we cover Eastern North Carolina, but you can see there's offices all over the country to serve your needs. As far as our local office, we cover the eastern quarter of North Carolina. Everywhere shaded in yellow, we do a forecast for. So you notice that does include the local sounds and out to 20 nautical miles. So if you've been on a boat, if you've been to the beach, if you've been on the river, we do a forecast for the marine areas. We do a land forecast, high and low temperature. Is it going to rain? Things of that nature. Out in the blue shaded area, this is beyond 20 nautical miles. We do a warning only for that area. And then the larger agency within the Weather Service, the Ocean Prediction Center, covers those folks out on the open seas. As far as Northeast North Carolina goes, Central North Carolina, or down toward Wilmington, that's where our sister offices cover. The Wakefield or Richmond office covers Northeast North Carolina, Raleigh covers the central part of the state, and then Wilmington covers the southeast part of the state. No matter what office you're covered by, we are open 24/7. So very much like police and fire and hospitals, we staff up for emergencies, or in our case, bad weather. And then when there's quiet weather, there's 2 of us here in the middle of the night, holidays and weekends. So the staffing just varies. But we do cover 24/7. Our staff is between about 20 and 25 people. And again, Monday to Friday, during the middle of the week, or during something like Hurricane Florence, everybody's here. Saturday night, quiet weather, there's only usually just a few of us to cover those shifts. The best way to get information, without a doubt, is our website, weather.gov. If you just remember the weather.gov part, you're good to go. You don't need the www. You don't even need the Newport for our local area. If you just go to weather.gov, that will pull up the national map. Then just click on the part of the country you're interested in. So for us, if you click across Eastern North Carolina, you'll get the Morehead City office. No matter what, no matter who covers you, all the information is the same. If you click anywhere on this map or enter your city or zip code, you can get a localized forecast. And it's pretty typical what you might see from your local broadcasters or even online. A 7-day forecast, how warm is it going to be? What's the wind speed the next couple of days? When is it going to rain? So pretty simple forecast. One difference with our website, if you scroll down on the page, you can get as much information as you want. A marine forecast, you can get an aviation forecast, you can get an hourly forecast. When is the highest chance for rain? When is the best chance that it's not going to be windy out during the day? So lots of details on that. This is the hourly weather forecast. It kind of defaults to the kitchen sink, shows you anything you want, and I like to uncheck things and then only leave checked what I want. So in this case, it's displaying temperature, wind speed, and cloud cover. Very, very useful, hour by hour, out to 7 days. You might say, well, Eric, I can get this on the phone. You can, but probably not the detail you can get from our website. Another way you can get weather information, especially during bad weather, is our weather briefings. If you scroll down on the page itself, underneath this map, there's a lot of icons, one of which is that Skywarn icon. So if you want to do spotter training, it's on that page there. But we're talking about weather hazard briefings, Florence, big winter storms, big severe outbreaks. We do a PDF of 5 to as much as 15 slides, and you can scroll through it. And again, if you've got a few minutes, you get a lot of information of what we anticipate. And these are a couple examples from Florence and a recent winter storm. We're big on social media. Please follow us, whether you're on Facebook, Twitter, or YouTube. And it depends on the medium what we put on there. So on Facebook and Twitter, it's a lot of what can you expect coming up. If there's a big weather event, we're waving our hands and saying you should pay attention to this. Whereas YouTube, we put a lot of our educational information, this talk, Skywarn training, things of that nature. When we do get a really big storm, like a hurricane, we will put our video recorded briefings on the YouTube page itself. Last but not least, one of the most asked questions I get is, do you have an app? And we don't have an official app in the Weather Service, but we have something just as good. If you go to mobile.weather.gov, and you really can do this anywhere, from your personal computer to your iPhone or Android to your tablet. This will work anywhere. But if you go to mobile.weather.gov, you can add this to your home screen. And if you don't know how to do that, just Google, I have an iPhone and I want to add it to my home screen. Lots of instructions are out there. And if you add this link to your home screen, a little icon of the Weather Service will pop up. By clicking on that, very similar to an app, you can have an hourly forecast for where you live. So a lot of good information. So that's the homework part of this class. The quick and dirty, who we are, what we do, where you can find the information from us. Again, some of you have taken these classes with us, and you might say, Eric, I've already heard it. Please keep in mind that some folks, this is their first time around. So we always like to talk a little bit about ourselves first, then we'll get to what the class is about. And today we're talking about severe weather, specifically tornadoes, lightning, and flash flooding. So, severe weather, springtime types of weather across our area. As far as thunderstorms go, we get them all 50 states. We do get thunderstorms even up in Alaska. You'll notice the cooler areas across the Pacific Northwest up toward Maine. They average 20 to 30 days a year, so not as many as the farther south you go. A much higher threat for thunderstorms. Anywhere from the central part of the country southward usually sees more than 50 days. Here in the Carolinas, 40 to 50 days on average. Sometimes it can be a little higher depending on the year. And then the highest amount is down across Florida, where they can have 80 to 100 days a year with thunderstorms. As far as thunderstorms go, you need certain ingredients in place for them to happen. We cover this in our Skywarn classes because it's important to know why things happen if you're going to report it. So you need these certain conditions for the thunderstorm to happen. And the three basic ingredients are moisture, some type of lift, and instability in the atmosphere. And moisture is pretty easy. If you have clouds, you have enough moisture. And we have a lot of sources of moisture here across our area because we're so close to the ocean itself. A lifting mechanism is really what triggers the thunderstorm to happen. And this is why we talk about cold fronts and warm fronts and low pressure systems a lot, because those are the triggers or lifting mechanisms in our atmosphere. And the last ingredient, instability. The ability of the air to rise. If you have high instability, that ability is higher. So think of warm and humid days here at ground level, and as you get higher in the atmosphere, if it gets really cold quickly, or if you're turning colder in terms of it's a hot day today, but it's going to be cold tomorrow, that can provide some instability. Now, you're not expected to remember all that, but the important thing about that is just like a recipe, brownies, your favorite cookie batch or a cake, if you forget an ingredient, it's not going to work out. So if you don't have the moisture, you don't have the instability, if all the ingredients aren't in place, you aren't going to get thunderstorms. You can kind of see this in the atmosphere in terms of how things work out. Let's see if I can get this video to play. Let me hop. Okay, there we go. Okay, so you can see this, this is a time lapse of clouds and eventually showers and thunderstorms. And if you look at this, you can see the clouds bubbling up. So you've got your moisture, you have your instability and some type of lift because they're rising in the atmosphere. And this is how it looks like with a time lapse of clouds forming. if we don't have enough lift or instability, the clouds never get large enough and they don't grow enough to produce thunderstorms. So this is how rising air looks in the atmosphere. And you can see in this day, it's taking a long time, but these clouds on the right are finally growing enough, getting big enough that they'll eventually start to produce a thunderstorm. And you can see that toward the end, the storm itself is rising. So all three ingredients are present. We've got the moisture, we can see the clouds, we've got the instability because they're bubbling up, but it really took that added lift to get the storm high enough and large enough to produce the rain itself. So that's a pretty neat time lapse there. All right, we're going to talk now a little bit about lightning. That's certainly one thing that can produce, it is producing a thunderstorm and it can be dangerous. Here's another video. I'm not sure how many of you have seen lightning before, but when you do, usually it's probably so quick that you don't really realize what's going on. So I'm going to play this video. Hopefully it's playing okay for you. And this is lightning slow motion. So you can see these little forks, step leaders that are reaching down toward the ground. And I'll play this a couple times, but they're reaching toward the ground. These are a negative charge and the ground is positively charged. And right when it makes the connection, that's when we actually see that stroke of lightning. This is what you would see to the naked eye. So I'll let it play again. And the way lightning forms is, in a storm itself, you have positive and negative charges. And eventually, the negative charges fall out toward the bottom of the cloud, and that's very important because the ground is positively charged. So positive charges go up toward the cloud, and then out of the bottom of the cloud, negative charges come down out. And where they meet in the middle, you have your stroke of lightning. So let's see if we can play this one more time so you can see that. It's pretty neat video, and again, this is slow motion. So that you can see it a little bit better. So let me go back here and see if I can turn this off. I'm going to turn the laser pointer off. All right. We'll go forward one and see if we can play this video one more time so that you can see the video. There we go. All right, so here we go again. Again, the negative charges are coming down out of the cloud itself. They send these little step leaders of lightning. They're searching, and as soon as they make contact with a positive charge near the ground, boom, and whatever first one reaches the ground, that's where you see the return stroke. And that's what you're usually seeing with the lightning itself at true speed when we don't slow it down. So that's a pretty neat video there. Just a couple facts: all thunderstorms produce lightning. That's why it's called a thunderstorm. And it can be deadly. We don't issue warnings for lightning because we would be issuing warnings, 40 to 50 days of the year, as you saw from that graphic. One important thing in terms of safety: lightning can strike 15 miles away, up to 15 miles away from the storm. And we had an incident of this up toward the Outer Banks last year. You're on the beach, it's sunny, overhead it's blue, and out over the water it's fine, but just inland you have some thunderstorms. If you can hear thunder, you are at risk for being struck. So please remember that. As far as being at home, lightning can travel through your wires and plumbing. So we always stress to, most of us have cordless phones or mobile devices now, but if it's charging, you don't want to be in contact with that. You don't want to be using water and things of that nature. This is a picture from a golf course where lightning had struck, and you can see in the middle and then how it spreads out. So that's why, being outside, especially near taller objects and things of that nature, can be dangerous because the lightning strikes one spot, but it doesn't just impact that spot. It spreads out, and that can cause obviously some issues. So safety outside: avoid water, anything high. The higher you are, the more likely you are to be struck. So standing by tall objects, like being under a tree, not a good idea. You certainly want to find shelter inside. That would be your best bet. A metal vehicle, so your car is actually a pretty safe place for a thunderstorm, if we're not talking tornadoes and high winds. Again, inside is the best, but if it's just your run-of-the-mill thunderstorm and there's a tremendous amount of lightning and you're out at a soccer game or a baseball game, your car protects you because of the metal cage around it, not the rubber tires, but the cage itself. Let's pretend this is our car. As the top of the car gets struck, the lightning would be dispersed on either side of the car, and then out through the rubber tires. Because of a concept known as the Faraday effect. So that will actually protect you. Once you're inside, that's the best place to be. Again, stay away from windows. Don't be taking a shower. We don't have a lot of corded phones anymore, but again, if your iPhone or Android is plugged in, that potentially can be a source of electricity into the house itself. So keep that in mind. Our big saying with that, with thunder, when thunder roars, goes indoors. Very, very catchy. But again, 10 to 15 miles away, lightning can strike you, even though where you are, it's clear blue out. So if you can hear the thunder, that's your biggest safety mechanism. You need to get inside. So now we're going to transition to tornadoes. This is a picture of a tornado back in 2014 in Belhaven, so we can certainly get them across eastern North Carolina. We tend to have a tornado-prone area, especially inland away from the coast. Places like Greenville, Snow Hill, up through Belhaven, Edenton, Plymouth, Washington, those types of areas. And then the whole area is at risk whenever we have a landfalling tropical system, whether it's a depression, a tropical storm, or even a hurricane. Here's a map of tornadoes across the country per year. Unlike the thunderstorm map, some states don't average a tornado each year. So out west, on average, they do not see a tornado each year, and same thing up across portions of Maine. With that said, every state has had a tornado at some point in their history. So in fact, the United States is the most tornado-prone nation in the world. We're going to talk about the reason why in a second, but notice a couple bullseyes. There's an area of higher probability across the Ohio Valley, Illinois, and Indiana. Another one across Florida. You know, again, they get so many thunderstorms, so that's not a surprise. And then another bullseye that you're probably more familiar with from Nebraska through Kansas, Oklahoma, and Texas. This is something called Tornado Alley, where they can average 7 to 9 tornadoes a year. So that's, you know, it may not sound like a lot, but that's you know, imagine if we had 7 to 9 hurricanes. Hopefully we don't this year, you know, impacting our area. That 7 to 9 is a significant amount. And one of the reasons why this is known as Tornado Alley is they are very favorable for thunderstorms and the conditions for tornadoes. Think back to the ingredients we talked about. Unless you have every single one of those ingredients in place, it's not going to happen. Unfortunately, the folks across the central part of the country often have the ingredients in place, and that's why it's more likely. Number one, you need moisture for thunderstorms and tornadoes. They're very close to the Gulf of Mexico, so any type of southerly wind can bring them warm, moist air. You need some type of instability, and you have it. You've got the warm air coming out of the Gulf of Mexico, and then the cold air coming out of the Rocky Mountains. So that clash of air masses can cause the instability. So we've got the warm, moist air, we've got the instability, and the last thing we need is an acting agent or some type of lift. Cold fronts and warm fronts are usually the separation between this warm and cold air, so we've got the lift in place for tornadoes. A couple other things that they have, very, very warm, dry air can descend out of the Rocky Mountains and the desert Southwest, higher altitude, and that can cause something called the dry line. That's another source of lift. It's just like a warm or cold front. It's acting to lift the unstable air ahead of it. And the other thing is, often when we get a big clash of air masses between warm and cold air, the jet stream is involved. And those are very, very strong winds high up in the atmosphere. They control our weather, but they can also aid for stronger winds getting mixed in with those tornadoes. When we talk about tornadoes, we use a scale. So the Saffir-Simpson scale goes from 1 to 5, and it rates hurricanes just based on wind. The enhanced Fujita scale does the same thing. It rates tornadoes based on wind or estimated damage. And once you get up toward an EF4 or EF5 with winds above 200 miles per hour, an anemometer really can't measure that. At that point, it's probably going to break, or whatever it's attached to is going to break. So we estimate the damage based, or the wind based on the damage. So if it's minor damage, maybe some damage to gutters and siding, it's toward the lower end. And then incredible damage, well-constructed homes stripped away from their foundation, that would be EF5. And again, it goes from 0 to 5, the stronger ones being up toward the 3, 4, or 5 on the scale. As far as tornado safety goes, if you're in a rural area, you really want to seek shelter inside. So we get a lot of questions, especially from younger students. What if I'm caught outside and I have no place to go? the best place is inside, no matter what. If you're caught off guard, as a last resort, you could seek shelter in a ditch, but you don't want to be in your car vehicle. Those can easily be picked up. You really want to drive to a secure building, a neighbor's house, some type of business. And you may say, well, what if it comes out of nowhere? You have environmental cues to let you know. We issue watches for a day that's favorable. Doesn't mean it's going to happen, but if there's a watch out that day, maybe you should stay closer to home. Maybe you should kind of get toward home if there's darkening skies. So you don't need to wait until it happens. If you hear thunder, if you see the skies are darkening and there's a threat for bad storms that day, start to make your way towards shelter instead of waiting until the last minute. Inside by far is the best place to be. Once you get inside a strong building, you want to be as low as possible and away from windows. So in my house, it's a 2-story house. I don't want to be in my attic. I don't want to be in my upstairs bedroom. I want to be downstairs. I don't want to be by the edge of the house because that's where my windows are. For us, it's our pantry or closet. Doesn't have windows. It's the center of the house. For us, our bathroom is actually toward the edge of the house, so that may not work. So sometimes we say bathrooms or closets, but just make sure it's centrally located and it doesn't have any windows. If you're lucky, especially if you're watching us from outside of Eastern North Carolina, you may have a basement that's underground. That by far is the best place to go to. This is a nice diagram to show you what we're talking about. Again, you don't want to be upstairs, bedrooms or attic. You preferably want to be in these green areas. So center part of your lowest level, so something without windows. And if you have a basement, that would be even better. Mobile homes are not safe during high winds. I know a lot of our homes are more secure and strapped down because of our coding with the hurricanes, but they still are a mobile home, so they can be lifted quite easily. This is not something you think about when the tornado's happening. Have a plan. If you have a neighbor with a more sturdy house, have that conversation to get to that location when the weather's bad. Have a local business you can go to, those types of things. Have a plan so when it happens, you're ready to go. The last thing we're going to talk about, because thunderstorms can produce tornadoes and high winds, but they can also produce flash flooding. And we see this in our area, especially in urban areas. We have a very sandy soil, so it's hard to get flash flooding in our area. The 2 exceptions would be urban areas or the Outer Banks, because some of those spots are near sea level to begin with, and they have high dunes. So you think of an impervious surface like a highway, and then you have dunes on either side. You can get ponding of water. Now, we certainly can get flooding during hurricanes, and that tends to be where we see our worst flash flooding. This is an example of flash flooding in an urban area with some terrain. This is Ellicott City, Maryland. I actually grew up in Columbia, about 5 to 10 minutes away. Very familiar with this location. It's a very steep area, and the city itself, the roads and things like that are impervious to water. So if it rains at a high rate and you have some terrain in areas that don't absorb the water, which is in the case of a city, you can get a bad flash flood. And they've had, unfortunately, a couple in the past couple years. If you're just joining us, we're just about to wrap things up, and then we'll turn it over to you for any questions. As far as flash flooding goes, cars can float in as little as just less than 2 feet of water, so it doesn't take a lot. As little as 6 inches can move somebody off their feet. So most flash flooding deaths occur in vehicles and at night. It's not that you're in your house and the water comes up all of a sudden and you didn't realize it. It's in cars and it's at night. It's preventable deaths. Our big campaign with that is turn around, don't drown. You don't want to go across a flooded road. You don't know how deep that water is, and you don't know if the road even exists. Look at what this water did to this road here. It scoured it out. Again, if there's water flowing across this and it's at night, you say, oh, that's a couple feet. I've got a big truck. It's a 4-wheel drive. I can go right through that. A, you don't know how fast that water's flowing. It could sweep you away. And B, you don't know if the road is even there. You're not crossing that, with a culvert that washed out. So the big campaign with that, again, when flooded, turn around, don't drown. Just take 6 inches of water to knock a human off their feet, and just a little less than 2 feet for a vehicle. All right, so it's about at the 25-minute mark. We try to keep our online classes between about 25 and 45 minutes. A big reason for that is I can't see if this is interesting or if you're paying attention. With an in-person class, we go up to an hour, and I can mix things up. I can ask you questions. I can make it more interactive. If you have any questions, please email me, eric.hayden@noaa.gov. You can visit our website.